Okay, section 4.5 is graphing sine and cosine functions. We are going to use our transformation skills in order to do this. So you can look back at chapter 1. Remember, all that stuff is still posted on Schoology, or it's linked to the agenda if you scroll down, and look back at your transformations essential skill. Maximum, minimum, odd, and even are defined for you. The way we talk about maximum in class is it says y's are increasing and then decreasing. So they're increasing and then they start decreasing. So the maximum of that is right here, which we often say top of a hill, and call that the max. And then minimum says y's are decreasing and then they start increasing. So the minimum is here. We call that bottom of a valley. And again, it's relative. So if you zoomed in really, really close and it looks like a parabola, that would be either a max if it's top of the hill or a min if it's bottom of the valley. Then even, odd, neither, we did that first semester. Mathematically, if you plug in negative x and you get the exact opposite equation out, that is an odd function. Whereas if you plug in negative x again and you get the exact same answer out, that is an even function. But we like to talk about the symmetry instead. So odd is when you can spin your graph upside down. You flip it over 180 degrees, rotate it 180 degrees, and it looks exactly the same. We say that is an odd function. And even is if you can fold it on the y-axis and it lands on top of itself, we say that's even. So we're going to start with the sine function. It is clearly already graphed there for you, so you know what the sine function is going to look like. But we need to talk about this table. So we have learned about the unit circle. If you have the unit circle, and we know we start here on the unit circle at 0 radians. That's what this 0 represents. This is radians on the unit circle. Because we are graphing sine, the y values represent the height. So at that point, sine has a value of 0. As you go around counterclockwise, if we stopped at pi over 4 radians, the height of the circle there would be root 2 over 2 because it is this distance that we're measuring, the vertical distance from the x-axis. Once we get to pi over 2, we have a height of 1. We keep going and we land at pi and we have a height of 0. Keep going and we get to 3 pi over 2 and that's down 1, so negative 1, until you're back where you started, 2 pi, 0. So we are going to use these ones. So I guess you can think of it as you need to memorize them, but I just showed you how to find them. That's stuff you need to know anyways for your evaluating skill. Just go around the unit circle and grab the y values. Then we're going to use our transformation skills to change those as the graphs transform. But let's talk about the graph as it is. The period for the sine function and cosine is the length of one cycle. So see how this is a curve up and then a curve down. And then it would repeat a curve up and then I ran out of space, but you know what I mean. And then this way, down and up, down and up. They repeat forever, but we graph what's called one period or one full cycle of the graph. If there are no transformations, the period's 2 pi. But down here, you can see once we start transforming it, the period will be 2 pi divided by b, and I'm going to go ahead and highlight that b pink. The amplitude is the height of a hill, so this distance. So I'm going to highlight the middle of this graph right here. You can kind of see that's the middle, right? That's where everything either goes up or down from. That's called the midline. I'm going to write that in green, actually. That's the midline of your sine curve. The amplitude is how high the hill is up from the midline, or technically it could be how low this valley is down from the midline. When there's no change, it's 1, but in the future, as we start changing things, it's going to be that A value. A is going to tell you your amplitude. Amplitude is always positive. When you answer amplitude questions, it's always positive. You can see what the sine curve looks like. Let's finish highlighting our transformation equation down at the bottom. Minus c and then plus d. I'm making this green on purpose because d tells you where the midline is. It's also your vertical shift. C is still your phase shift. This is all the same stuff from our transformations chapter, remembering back to that. And then I'm kind of out of space. I squeezed this all on one page, but you guys have enough space on yours. Remember our transformations formula, if you want to get the new x values, is x divided by b plus c, which is opposite of what's happening here. That says minus and I wrote plus, comma, ay plus d. So let's match up our colors. B comes from B. A is yellow. C is orange. And I'll try to do this for the rest of the chapter. C is orange. And D is green because it tells you our midline. So we're going to use that knowledge to help us graph sine and cosine. So let's go to our first example. Okay, here's our first example. Remember when we do transformations, it needs to be in graphing form. This one is, but I'm going to go ahead and write it in graphing form better. So y equals 2 sine bracket b is supposed to go in front of the parentheses, and since there's nothing there, you could put an imaginary 1 parentheses x minus pi, and I'm going to go ahead and put plus 0 just so I can highlight all the different things. So 0 is our d value, and it also tells us our vertical shift. In the parentheses, we're going to do opposite in a minute, but that tells you the phase shift. In front of the parentheses is b, that's going to help me answer the period. And in the very, very front is a, that's going to help me with amplitude, and is there a vertical reflection, yes or no? So looking at our graph, or our equation in graphing form, a is 2, so the amplitude is 2. This happens to be a positive answer, but remember this is always positive. I'm going to put a note here, and I'm going to put a note later, and then someone's going to forget on test day and get really annoyed that I took a point off because you forgot that it's always positive. Then because this a value actually is a positive 2 right there, there is no vertical reflection. Period is the equation 2 pi over b. B happened to be 1 in this problem. So then 2 pi divided by 1 is just 2 pi. Phase shift, the problem says minus pi, but remember that actually goes right pi. You could also draw an arrow symbol. And then plus 0 does nothing. It's not up or down. Then we need our original points for sine, and then we will transform them. So this is a sine graph, so we're going to do our original sine theta points. Remember, you can think of it as going around the unit circle counterclockwise, because that's the way we go around the unit circle. You start at 0, the sine, the height at 0 is 0. Then you make your way all the way up to the top at pi over 2, and the height there is 1. Then you make your way over to pi, and the height there is 0 again. Then you're down at 3 pi over 2, and you're down at negative 1, and then you make your way back to 2 pi, and you're back at 0. Notice that these three are the same. I don't know what color to make that. Let's make them this weird gray color. These three are the same because sine has the same value at those 3 spots, and technically the top spot and the bottom spot are the same spot on the unit circle. It's just whether you've gone around or whether you're just standing there. So then we're going to do our math, x over b. So we're going to take every x and divide it by the b value is 1, which I'm just going to write at the top, but obviously we don't need to divide by 1. It doesn't do anything. And it says minus pi, so we're going to add pi, the orange number. For every y value, we're going to do 2 times y, the yellow number. And plus 0, which I'm going to write up here, but obviously adding 0 doesn't do anything as well. So every x, we're going to do these things. And y, sorry. So x divided by 1. So just 0 plus pi. And then I'll do that in a second. Pi over 2 plus pi. pi plus pi, 3 pi over 2 plus pi, 2 pi plus pi. Let's finish the x's first. So that's going to give me pi. You're going to need to practice some fractions here. Remember, this is over 1, so times 2 on top and bottom, hopefully in your head. So that's pi over 2 plus 2 pi over 2, which would be 3 pi over 2. It's 2 pi. 3 pi over 2 plus 2 pi over 2 is 5 pi over 2. And then 2 pi plus pi is 3 pi. Then go through and double all your y's. You also don't need to fill this in. Obviously, this one's relatively simple. You can double things in your head. That's just fine. I'm going to show it just for notes' sake. And then do the math. And those same 3 numbers should be the same. So when I say the same, they don't have to be the same as the gray numbers. That's a coincidence. But they should be the same as each other when you're done. And this is our new, I wish we hadn't called this one y, but this is our new y points that we're going to plot. Okay, so for setting up your axes, look at your new points under the y column. And first of all, look at the x's. They're all positive, so I don't need any space in the negative. And then look at your y's. Those are pretty much split. They go all the way up to 2 and all the way down to -2. So center your x-axis. When you're figuring out your tick marks, which you do have to draw and label on your tests and worksheets and everything else, notice the smallest denominator, or notice the denominator is 2. The only one you see is over 2. So we're going to count by pi over 2's. So 1 pi over 2, 2 pi over 2. I'm going to label it 2 pi over 2, but realize that's just pi. 3 pi over 2, 4 pi over 2, 5 pi over 2, and then 6 pi over 2, but that's 3 pi, so that's just far enough. We will always assume your y-axis goes by 1s, but show the tick marks. 1, 2, 3 is enough. 1, 2, 3 is enough. Try to keep them balanced. And then we're going to plot those new points. At pi, 2 pi over 2, it has a value of 0. At 3 pi over 2, it has a value of 2. You should also notice that these are symmetric. So if one of your answers for your x's isn't an equal distance, you probably did something wrong. At 4 pi over 2, 2 pi, it's back to 0. At 5 pi over 2, it's down to -2. And at 6 pi over 2, it's back to 0 again. Notice those 3 points land on your midline, and my midline is still the x-axis because there was no vertical transformation. Try to make it curvy and look like a sine curve. Sometimes it's helpful to continue the graph. Remember, we're just graphing one period, but this does continue this way, up, and then down, and then it also continues this way, down, and then up. And when I do that, I notice that my y-intercept is right on the origin, and that's going to be important in a second. So here come all the rest of the answer blanks, because you know those weren't our only answer blanks, right? There's other stuff we need to answer after we graph it. So we've got domain and range. We've got relative min and relative max. We're going to want the y-intercept. Is it even, odd, or neither? And are there any asymptotes? Okay, so again, we graph one cycle, one period of sine and cosine and everything else, but it goes on forever. So the domain is going to be all real numbers. The graph actually goes on forever. Range, bottom lowest point I see is at -2, bracket, because it touches -2. The highest this sine curve goes is +2. The relative minimum, I'm going to make that blue. If I look at the solid graph the one period I graphed, there's the relative minimum. It is at 5 pi over 2. But that's not going to be the only relative minimum of the graph, right? It keeps continuing. For example, here's another one over here. So we can't just list these out forever. There's an infinite number of relative minimums, but the distance between them is always going to be the period. So if you see, I'm running out of colors, you guys. If you see this distance here, that's the period. So to show that they repeat every period, you show plus or minus. The period for this one was 2 pi, and then you put an n at the end so that it keeps going plus or minus 2 pi forever. So it repeats every possible x value for those relative minimums. And then the y value for all of those relative minimums was, that's a weird color, at -2. So this is how you answer it. And this came in pink from our period. Same idea for relative max. Relative max, top of a hill in our solid curve is right there. That one that I happen to have graphed is at 3 pi over 2. But they repeat every period, so plus or minus 2 pi n. And the y value of the maximum is +2. Notice that these are parentheses. That's because these are points. So these are always parentheses. This is an interval. Domain and range are intervals, so sometimes those are brackets. But mins and maxes are points, so always use parentheses. Y-intercept, because I backed up this graph all the way to the y-axis, I was able to easily see it goes through 0, 0. Because it goes through 0, 0, remember your odd and even? If it goes through, or I should say, if the midline is at 0, 0, it's going to be odd. Because if you continue your graph and it goes up here and then it curves back down, and you take, because yours is on paper, and you flip it upside down, it's going to look just like mine looks. It doesn't change anything when you rotate your paper 180 degrees. So this one is odd, and sine has no asymptotes. That's why I didn't teach you anything about asymptotes. But if the answer blank is there, you write does not exist. Okay, this was our first full sine example. This is everything you can be expected to be asked. Let's move on and do the next one and see how we can do. Okay, again, in order to get started, it needs to be in graphing form. If I write this properly in graphing form, it's -1 sine, and then bracket. Remember, this parentheses always needs to be a single positive x from our transformations unit. So that means I need to factor that 3 out. So that means I'm dividing by 3. When something is already a fraction and you're dividing by 3, that's the same, excuse me, I have the hiccups, as multiplying by 1 over 3. So basically, if you just multiply the denominator by whatever you're dividing by, it's going to give me plus pi over 6 bracket, and then still -2. I'm going to color code these. You do you. The -1 is going to tell us about our amplitude and our reflection. The 3 is going to tell us about the period. The plus pi over 6 is going to tell me about the phase shift. And the -2 is going to tell me about the vertical shift. That's also our midline. So go ahead and write down what the amplitude is. What's the amplitude of this graph? Did you write down +1? Because the amplitude is always positive. It is a height. It's the height of the hill. Heights cannot be negative. But since it was a -1, A was a -1 in the equation, that means, yes, it has a vertical reflection. So that means instead of sine going up and then down like this, our graph is going to go down and then up like that. Period, 2 pi divided by the b value, which ends up being 2 pi over 3. Phase shift, it says x plus pi over 6, so that's actually going to move it left pi over 6. And then vertical shift, it says -2, that's going to move it down 2. So see if you can set up your table with all the points of sine. There's 5 points that we use to get a good sketch of sine. See if you can write those down in the table. Okay, check your sine theta points with mine. Then at the top of our table, right here, see if you can write what math we're going to do to the x's and the y's. Pause your video and see if you can come up with those equations. Okay, check yours with mine. So x divided by b, so x over 3. And then the problem says plus pi over 6, so you're going to minus pi over 6. Do the opposite. Remember, once we write our new equation down, don't look at this one anymore. Just look at the equation we wrote. AY plus D, negative 1y minus 2. So 0 is not as important, but 0 divided by 3 minus pi over 6. Pi over 2 divided by 3 minus pi over 6. I will never write it like that again. When you have a fraction and you're wanting to divide that fraction, instead, I just said it earlier, multiply the bottom by what you're trying to divide by. So we are doing pi over 2 divided by 3, so 2 times 3 is 6. Pi over 6 minus pi over 6. Pi over 3 minus pi over 6. 3 pi over 2 divided by 3 is 3 pi over 6 minus pi over 6. 2 pi over 3 minus pi over 6. Let's work on those first. So we're going to do 0 minus pi over 6 is negative pi over 6. Pi over 6 minus pi over 6 is 0. Remember, make common denominators. So that's 2 pi over 6 minus pi over 6, which is pi over 6. And then at this point, you should catch on to the gaps. This is a pi over 6 gap. This is a pi over 6 gap. If I did this right, that's going to repeat. So, and I don't know why I'm using black, but it's fine. So add another pi over 6 and I get 2 pi over 6, and it's perfectly fine to not reduce these. Add another pi over 6 and I get 3 pi over 6. And you can check by doing the actual equation math over there that I got those right. Y's. See if you can fill in your Y's. Okay, check your Y's with mine. This table took up a lot of space, so I'm going to graph it down below. Look at your X's. I have a negative pi over 6, so that's not very much in the negatives. So I'm going to leave a little space to the left. Negative 1 to negative 3 is where my Y values go, so I don't need any space up above. If I look at my denominators, the biggest denominator, so the smallest number has the biggest denominator, is pi over 6, so I'm going to count by pi over 6. Mine happens to be on graph paper, so I can evenly space those out. Negative pi over 6, pi over 6, 2 pi over 6, 3 pi over 6, and that's actually as far as my graph goes. I know mine's on graph paper, but I'm going to go 2 tick marks and call it 1, 2, 3. So they're just evenly spaced. That's all the graph paper does for me. Go ahead and plot those points. And then try to make it curvy like a wave, a sine, graph, function. Remember, it repeats. This would go on forever. You don't need to draw that. This would go on forever. Okay, I went ahead and put the rest of our answer blanks. Take a second and see how many of those answer blanks you can fill out. Pause the video so you can try it on your own. I'm going to start going over them. Domain for all sine functions is all real numbers. They all go on forever, left and right. Use every x value. Range, the lowest my graph goes, it touches, so bracket, negative 3. The highest my graph goes, it touches, bracket, negative 1. Bottom to top, always smallest to biggest. Relative minimum, the bottom of a valley, happens here, but it repeats every period. So that point is at 0, but the period, plus or minus, is 2 pi over 3, from my answer blank up above, n, so that it repeats every period, and the minimum value there is negative 3. Relative maximum, I have one of them graphed. That one that I have graphed is at 2 pi over 6. You're welcome to leave it non-reduced, but if you're doing a multiple choice test or if you're checking with the book, they're probably going to reduce that, but I'm fine with you leaving it in non-reduced form. 2 pi over 6 every period, plus or minus 2 pi over 3n, and that value is at -1. Y-intercept showed up in my table, in my table, 0, -3. That has a minimum on the y-axis, so hopefully you can see by me connecting with the dotted lines, if you folded it on the y-axis, they would land on each other. This point that I'm making extra big would land on this point, etc. So this is even, and asymptotes do not exist for sine graphs. Okay, pause the video here if you're still catching up, and then let's try cosine. So cosine, again, we've got the table there for you, the graph there for you. We're going to focus on these 5 points, and they come from the unit circle. If you're going around counterclockwise and you're starting at 0 radians, the cosine value is the x value, right? The unit circle has a radius of 1, so cosine right there is 1. So that's the point 0, 1. If I go up here, I'm at pi over 2. The x value there is 0. If I go around over here, I'm at pi. The x value there is left, so -1. Down to here, 3 pi over 2 has an x value of 0. And when I'm back to my starting point, I'm at 2 pi and 1. So that's where those yellow numbers come from. They've been sketched on the right-hand side for you. Same stuff applies. So that midline is our green line. It's our vertical shift. The amplitude is the height of a hill. Amplitude's always going to be positive. The period of the graph is going to be the distance between a full cycle. So notice cosine starts at the top of a hill, goes all the way down through the midline to the bottom of a valley, all the way back up to the top of a hill. So it looks different than the sine curve, which is why we only graph one period of it, because if I kept this going forever, you wouldn't be able to tell if it was supposed to be sine or cosine, because depending on where you start, if I started here in a different color, and I just graphed from here down, up, and down, that orange piece can be represented by sine. So we graph one period so that we can easily tell what we were trying to graph. The period is found down here, same way, 2 pi divided by b. It is the absolute value of b, by the way. A period is a length of time. The length of time is never going to be negative. There's b, pink, a in front, amplitude, yellow. C tells us our phase shift, always opposite. And D is going to give us our vertical shift, which is also our midline. Same steps and rules as before, we just have 5 different points to start with. Here's our example for cosine. Let's first write it in graphing form. This is not written in graphing form over here, y equals. Pause the video and see if you can get this to graphing form. Okay, check your graphing form with mine. 1/3 is going to help us with amplitude vertical reflection. That 4 is going to help me with the period. When you divide by 4, you get minus pi over 4 for your C value, which will tell us phase shift. And the -1 will tell me my vertical shift, and is also going to be the midline of my graph. See how many of those answer blanks you can fill in. You are, again, welcome to leave the period as 2 pi over 4, but if you're doing a multiple choice quiz or checking with the book, they're probably going to write it as pi over 2 in reduced form, but it's actually more helpful if we leave it in that form as we start doing some of the math. Phase shift, it says minus, so that's actually right pi over 4. Remember, we're not looking here anymore. We're only looking at the one we wrote. Vertical shift is down 1. See if you can fill in the cosine table that we're going to need in order to be able to graph this form transformation. So those are the original points from cosine. You could just flip back if you're not great at the unit circle yet, but we are improving on our unit circle, I hope. Then see if you can write your formulas for finding the new points. X, are we going to write divided by 1/3? What's the same thing as dividing by 1/3? Or instead of multiplying by 1/3, what's the opposite of that? multiply by 3, 3x, and then plus pi over 4. Actually, why are we using the a value and we're supposed to be using the b value? Let's use the b value this time. X divided by the b value is 4, if we're looking in the right spot. The parentheses say minus, so we're going to do plus pi over 4. 1/3 is used for the y, because it's the a value, minus 1. So let me finish color coding this. See how much of that math you can do. Feel free to pause the video instead of watching me do it. And actually, I'm just going to do them all as I write it. So 0 divided by 4 plus pi over 4 is pi over 4. Remember, I'm not going to write pi over 2 over another thing. We don't write fractions and fractions. So if I have pi over 2 and I'm dividing by 4, 2 times 4 is pi over 8 plus pi over 4. Also, you're welcome to write it this way instead. Pi over 4 is 2 pi over 8, if that helps you. So pi plus 2 pi gives me 3 pi over 8. Pi over 4 plus pi over 4. That's going to give me 2 pi over 4. If I'm looking to use that shortcut I said earlier, I should make these all the same. This is 2 pi over 8, 3 pi over 8. This becomes 4 pi over 8. If you keep common denominators, you can see the pattern better. So the next one should come out to be 5 pi over 8, and my last one should come out to be 6 pi over 8. You are welcome to just catch on to your pattern. As long as you did the first couple right, it should be right for the rest of them. 1/3 y minus 1. 1/3 minus 1 is negative 2/3. 0 minus 1. Negative 1/3 minus 1 is negative 1 1/3, or negative 4/3 if you'd prefer. This is going to be the same, negative 1, and then I'm going to land where I started earlier, so negative 2/3. I didn't even have to do very many of those. See if you can set up your axes. Look at your x's, nothing in the negative, so I'm not going to, nothing in the negative, so I'm not going to need any negative space. I am leaving some room for my answer blanks though, so I'm going to start my graph right here. And my y's are all negative, so I don't need anything up above, but I like mine to be on graph paper, so I'm going to put it on the graph paper. My denominators are all 8s, so I'm going to count by 8s. 1/8, 2/8. That's enough. I don't have to label every single one. I just have to label a couple. 2, 3, 4, 5, 6/8 is as far as my graph goes. And then I'm dealing with thirds. So since I'm on graph paper, I'm going to go 3 down, 1, 2, 3, and call that negative 1, so I can easily see the thirds. 1, 2, 3 would be negative 2. Scale it however you want, as long as you label it. And then let's plot those points. See, by leaving my graph paper there, I could see where negative 2/3 was easier. Negative 1, negative 1 1/3, back to negative 1, and back to negative 2/3. Okay, when you plot your cosine points, they are clearly going to make a V shape. That is what the points that we chose, the 5 points, will do if you just plot the points. But from the previous page, you know it's supposed to be a curve. It's supposed to be part of a cosine curve. So I need you to make it look like this is where it's going downhill. It becomes a little valley and it curves back uphill. It's supposed to be curvy. If you make them super sharp and make it look like a V, it will be marked wrong. See how many answer blanks you can remember and how many answer blanks you can fill in. Okay, there are some of the answer blanks. I'm going to start filling them in quickly. There are two relative max that show up in the graph. I think I was doing minimums blue. So there was only one to choose from, but you'll have two maxes to choose from. I just always tend to write down the one on the left, but the plus minus pi or period n will take care of hitting both of them. So if you choose 6 pi over 8, that's not wrong. I just always write the one on the left as my answer. But plus minus 2 pi over 4n will hit the other one as well. I didn't write y-intercept because I need some space to do that. Asymptotes do not exist, and y-intercept will help me with my even odd neither. So you could repeat the graph, but as they get further and further from the y-axis, that becomes a pain. And theoretically, on the multiple choice test or question, I could just ask you, hey, what's the y-intercept for this? And you don't want to have to go through all this work to graph it just to find the y-intercept. So y-intercept, just like an integrated 1, plug in 0 for your x. So 1/3 cosine. And just go ahead and plug it into the original function. You should notice that you just get negative pi out of that. And then minus 1. So that is a negative pi. When I plug in 0, I get this left. Then this is part of your evaluating skill. Negative pi is this way half a circle. And I land right here. Y equals 1/3. What is cosine right there? Well, it's left 1, so negative 1 minus 1. This is negative 1/3 minus 1, which is negative 1 and a third. So for my answer, it's 0, negative 1 and a third. But you should notice negative 1 and a third is the same as your minimum value. When a minimum or a maximum lands on the y-axis, that makes it even, because you could fold it perfectly and it would land on itself. Okay, one more problem. What if you're basically given a graph and you need to find the equation? So feel free to read up above and see what they're talking about and what these points represent. But honestly, they give you a graph, so it doesn't even matter. We have everything we need just looking at our graph. So first, notice the midline, the point where all our x-intercepts lie, is at 0. That means there's no vertical shift. If all of your intercepts, if all of those middle points, is how I should phrase it, land on the x-axis, then you have no vertical shift. For amplitude, the height of a hill, you can see that this distance is 65 because that's given on your y-axis. For a period, the time from beginning of the cycle to the end of the cycle, you can see that it goes from 0 to 40. So period is 40. Okay, I think that's all we need. And then obviously it's a sine curve as well, right? They give you one cycle and you can see that it's the sine curve. So I answered period is 40, amplitude is 65, and now the equation. So the equation is y equals, make it an equation. Amplitude goes in front, 65. We said this is a sine curve. The b value is supposed to go there, x. Oh, there's also no phase shift, right? If the first point is right on the y-axis, there's no phase. So this is just going to be x by itself. Bracket. And then we said there was no vertical shift, so plus 0 if you want, or I'm just going to stop right there. What we need to figure out is b, because 40 does not go here. Remember, the equation is the period is equal to 2 pi divided by b. So earlier I said the period was 40. So 40 equals 2 pi divided by b, cross multiply, 40b equals 2 pi. I'm solving for b, so divide by 40. That makes b 2 pi over 40. So the number that you actually write there, b, is 2 pi over 40. And then that would get us points, or the equation of the points that they gave us earlier. For b, use the equation to estimate the change in line of sight velocity on day 36. So plug in, because days is our x-axis, plug in 36. this would be a calculator question. If you were to do this on a calculator, when you see the pi symbol in your equation, that's how you know you're doing radians. So that means you need to be in radian mode. So change your calculator to radian mode and then type this equation in with all these parentheses. Instead of brackets, you would just use parentheses, right? So 2 sets of parentheses. And you should get negative 38.206 meters per second is what the y-axis represents. But once you've done that and you've gotten the answer, change it back to degrees. More often, we need your calculator in degree mode. Before you turn this video off, change your calculator back to degrees. Okay, we will talk about this more in class. I hope you guys are doing good.